A colossal plume of order is cutting across the chaos of our solar system, and it belongs to the interstellar object, 3I, Atlas. For months, the official line has tried to dismiss this visitor as a simple, dusty comet, but the latest razor-sharp image analysis is now delivering visual evidence that is mathematically impossible for a natural ice ball. We are not talking about blurry pictures or subtle readings. We are looking at impossible geometry etched into space itself. This object is projecting plumes of gas and dust that are perfectly straight, precisely perpendicular to the sun, and utterly defiant of every known law of fluid dynamics for a fragile, tumbling nucleus. This isn't just an anomaly, it's a consistent structural statement about the object's internal nature. Why would nature waste so much energy constructing such highly ordered, right-angled exhausts? The new data forces us to move past chemical debates and confront a terrifying reality. The core of 3I Atlas must contain an internal framework, a kind of engine or channel system, that is actively generating this visual order. We are about to dissect the images that prove these jets are not random outgassing, but the product of a highly ordered, rigid internal machine. What kind of enduring structure beneath the surface is strong enough to maintain such geometric perfection across billions of kilometers of flight? The time for comfortable dismissal is over. The new image stacks have zeroed in on the Rotational Collimation factories of the 3I Atlas jets, and the numbers defy the very definition of a comet. Collimation is the measure of how tightly packed and parallel the flow of particles remains over distance. In a natural comet, the jets disperse quickly, creating a fan or a cone shape due to low initial velocity and the total lack of nozzle structure. Atlas, however, exhibits a near zero deviation, less than 1/10 of a degree, over tens of thousands of kilometers. This level of precision requires the material to exit through extremely narrow, deep, and perfectly aligned internal nozzles that maintain the pressure gradient all the way to the exit plane. This focused output is analogous to a high-powered water cannon versus a leaky garden hose. The difference in effective range and precision is astronomical, and in the low-gravity, high-heat environment of a comet, this sustained collimation simply shouldn't exist. This high collimation instantly eliminates random surface cracks or shallow ice pockets as a possible source. Random vents would create chaotic, multi-directional flow, but Atlas produces an output that appears to be actively shaped and focused by an enduring internal framework. The persistence of this zero-deviation anomaly means the internal channeling must be composed of a material dense enough to maintain its shape against the explosive forces of sublimating ice, which would otherwise quickly erode and widen the aperture. We are observing Warke non-cometary fluid dynamics, enforced by material strength. The pressure differential needed to maintain this level of flow control confirms that the gas is being channeled through a sophisticated resistant pathway rather than leaking out of a fragile, porous sponge. The mathematical perfection of the plume is the object's first structural proof. The core implication is that the structural component of the object is actively resisting the very forces it is generating. The nozzle walls must be harder than the escaping gas pressure, which is a massive contradiction for a body composed primarily of ice and dust. This tight collimation is a visual representation of immense, controlled internal pressure. The persistence of the jet's straightness forces us to confront the extreme demands of the Fermi ejection velocity paradox. 3I Atlas is spinning rapidly once every 16 hours or so. When a comet vents gas, the Coriolis effect, caused by this rotation, instantly begins to curve and distort the trajectory of the slower-moving gas. For the jets to remain ruler straight as they escape the nucleus, the plumes of gas and dust must be moving at an extreme kinematic output, a velocity so high that the material is ejected before the nucleus's rotation can effectively warp the flow. This unprecedented velocity requires an immense internal pressure system, a phenomenon that hints at a sophisticated mechanism for kinetic energy conversion. A natural aggregate could never contain and sustain this level of pressure without suffering catastrophic internal failure, causing the whole fragile body to rupture. This stability implies that the nucleus is built to withstand and deliberately utilize internal forces vastly greater than those required for simple outgassing. The energy source required to propel tons of material at these extreme, focused speeds, overcoming the drag and the rotational pull, is a major unanswered question. It suggests a non-standard energy source, possibly related to the object's unusual chemical makeup or a stored energy reservoir within the dense core. The straightness is not just a visual curiosity, it is a mapavra, measure of the object's sheer propulsive power. Shaki, proving that the source is more controlled and durable than any known solar system object. The object's defiance of the curve is a kinematic confession, proving that its core material possesses both the tensile strength to contain the pressure and the structural integrity to direct it into a perfectly straight line. This high-velocity escape is the engine's signature. The perpendicular angle of the jets, 90 degrees to the sun's radiation, suggests the existence of a robust thermal shield. For the jets to be focused and perpendicular, the sublimating material must be forced to travel laterally through the core, away from the hottest surface, before exiting specific cold side vent points. This is only possible if the majority of the object's sun-facing surface is protected by an incredibly thick, non-conductive layer and/or insulating armor that prevents direct solar heating from causing general outgassing. This engineered thermal gradient ensures that the internal ice only sublimates in specific controlled regions deep beneath the surface, feeding the rigid channels. A traditional comet surface is an inefficient mix of dark dust and patches of ice, leading to chaotic multi-directional sublimation. Atlas's uniform, stable jet production points to an engineered thermal management system, highest serum, deliberately routing heat and pressure to the designated structurally maintained exit points. The core of this mystery is the Phytsu Ara materials science. On of the shield, it must be composed of light, yet extremely durable, porous, and highly non-conductive materials, a requirement that screams of advanced composite engineering rather than random cosmic accretion. Without this shield, the perpendicular jets would be instantly overwhelmed by general sun-facing outgassing, rendering them invisible. The purity of the side jets is a testament to the effectiveness of the object's internal insulation. It implies a layered, sophisticated design where the surface is deliberately hardened to maintain structural and thermal control. The geometry is the blueprint of an impossible internal machine, relying on an anomalous thermal architecture to function. The lack of violent, chaotic motion is the deepest structural puzzle, leading to the rotational damping mystery. Every focused jet emission, even if small, creates high torque, a force that should cause the nucleus to wobble, precess, and tumble uncontrollably. Since the jets of 3I Atlas are not perfectly aligned with the center of mass, the total torque should have ripped it apart or sent it into an impossible, unstable spin. Yet 3I Atlas maintains a relatively regular rotation, resisting this induced chaos. The only physical way to account for this stability without catastrophic failure is the presence of an internal, active stabilization system. This could manifest as perfect continuous counterbalancing jets, firing with exactly equal and opposite thrust, a statistical impossibility for a natural process. More chillingly, it suggests a system analogous to a reaction wheel assembly or an internal gyroscope deliberately built into the core to absorb and counteract the rotational momentum generated by the high-velocity plumes. This internal mechanism must constantly detect the minor wobble and apply a counter force to maintain equilibrium. The object's refusal to tumble is evidence of an inner gyroscope, constantly fighting the forces of its own propulsion system. This requires sensors, actuators, and an energy source, all hallmarks of engineering, not geology. The lack of chaotic motion is the silent witness to an inner equilibrium system, proving that the object's structural integrity is not passive. It is dynamically managed. The stable spin is a direct measure of the effectiveness of this unseen internal control mechanism, adding a layer of controlled intelligence to the structural anomaly. Focusing on the vent structure, the jet geometry strongly implies subsurface plumbing that shows evidence of molding versus erosion. In a natural comet, the vent channel would be eroded by the high-pressure gas passing through it, leading to a visible flaring or widening at the exit aperture. The collimated jets of Atlas show no such flaring. They maintain their tight focus right up to the point of emission. This lack of erosion suggests that the material lining the vent channels possesses an extreme resistance to sublimation and abrasion, a kind of internal ceramic or metallic lining that maintains the structural integrity of the conduit over billions of years. These conduits are not weak tunnels carved by escaping gas. They are rigid tubes that direct the flow. The vents themselves must be deep, reaching beneath the thermal shield, and consistently narrow. This requires them to be anchored to the presumed high-density monolithic core, rather than the porous outer layers. The structure is one of intentional channeling, designed to prioritize flow velocity and collimation over material efficiency. The straightness of the plume is literally tracing the perfect, non-degrading lines of this durable internal architecture. The plumes are not a random leak. They are the precisely guided output of a durable internal engine, proving that the object's core infrastructure is composed of materials built for persistence and control. The simple lack of flaring is the final forensic proof of engineered resistance. The subtle details in the light curves and spectroscopic data point to a highly organized pulse signature and consistency scar in the jet emission. While visually the jets appear continuous, high-frequency spectroscopic analysis detects slight rhythmic variations in intensity, suggesting a near-continuous output maintained by small, highly consistent, regulated pulses. This is not the chaotic clearing of an ice patch. It is the systematic managed discharge of internal pressure. A natural comet vents chaotically, driven purely by the random exposure and depletion of surface ice. The controlled rhythmic pulsing of Atlas implies a sophisticated, steady-state pressure regulation system. Within the nucleus, a complex mechanism controlling the flow rate into the rigid channels. This requires sensors to measure the internal pressure and actuators to manage the venting aperture. This managed consistency suggests a stable power source and a regulatory mechanism controlling the flow rate with precision that is wholly inconsistent with chaotic ice mechanics. The plumes are not a random event. They are a controlled discharge, pointing to an internal mechanism that manages pressure, temperature, and material flow with machine-like accuracy. The consistency of the discharge pulses is the signature of an engineered cycle, proving that the core is not a static body, but a dynamically active system, constantly regulating its output. This stability is a profound rejection of the volatility expected from an icy body in the harsh vacuum of space. The magnetic resilience of 3I Atlas provides a stunning structural test case when it crosses the complex boundary of the heliospheric current sheet. The current sheet is a massive, warped surface that subjects the jet plumes to rapidly changing magnetic field lines. While the object's ion tail was briefly warped, the main plumes of neutral material exhibited a defiant, persistent straightness, rapidly regaining their structural integrity after crossing the magnetic boundary. This resilience against fluctuating magnetic forces suggests that the majority of the jet's momentum is carried by neutral, high-mass molecular components, molecules too heavy and complex to be easily pushed by the sun's magnetic field. This is physical proof that the object's output is kinematically dominant over the sun's magnetic influence, reinforcing the extreme velocity hypothesis. This observation is critical because it reveals a potential alien shielding property, an object that can shrug off the magnetic chaos of the sun's current sheet is far better equipped for long-term survival in the interstellar void, where various stellar magnetic fields and high-energy particles constantly barrage travelers. The magnetic stability is physical proof of the object's superior shielding capabilities. The plumes are not just gas, they are evidence that the nucleus is venting highly complex heavy molecules from a deep shielded core, confirming a composition that is both unique and structurally necessary for its high mass output. The structural demands of the jet channels and the internal shield lead us directly to the required alien materials requirement. What substance could form and maintain the internal plumbing and the external thermal shield over billions of years of cosmic travel? It must be a material with an exceptional combination of high tensile strength, resistance to thermal shock, and immunity to sublimation erosion. We are looking for something beyond simple rock or ice. Highly refractory compounds, perhaps like a ceramic metallic, cermet, composites, or complex graphite silicate structures that have never been observed in a cometary nucleus. These materials would provide the strength necessary to maintain the rigid channel walls and the thermal resistance for the shield. The continuous stability of the jets necessitates an internal framework made of these exotic materials, a structural skeleton that maintains its geometry, regardless of the changing internal pressures or external temperatures. This endurance is the final piece of the puzzle, suggesting a construction material built not for a short orbital life, but for the vast, deep survival of interstellar transit. The persistence of the plumbing system is not just an anomaly, it is an engineering failure analysis, proving that the components are built from materials that defy the expectations of natural aggregation. The jets are the visual signature of a technologically advanced material science. The absolute precession failure of the jets is the final unassailable piece of evidence against the natural model. Precession is the predictable wobble experienced by any spinning object when an off-axis force is applied. Since the jets of 3I Atlas are continually forcing the nucleus off-center, they must cause a violent wobble. Yet high-precision tracking reveals the nucleus wobble is minimal. It is being actively suppressed. This suppression proves the object is not just countering the torque, but also counteracting the wobble itself. Via a sophisticated control mechanism, this requires an active feedback loop, a system of internal sensors to detect the precise angle of the wobble and actuators to instantly apply corrective mass shifts or counter thrusts. The object is, in effect, performing a constant, complex, attitude-controlled maneuver. A simple aggregate of rock and ice cannot perform this continuous self-correction. The only explanation is a structured, centrally controlled, and highly precise dynamic stabilization system built into its core. The absence of expected violent wobbling, the precession failure, is the geometric confirmation of a machine. This complexity elevates the object from a mere anomaly to an artifact. It is a system that thinks, measures, and corrects its own motion against the laws of celestial mechanics. The convergence of all these analyses, the zero-deviation collimation, the precession failure, the kinematic velocity, and the endurance of the thermal shield, has led to an irreversible scientific conclusion. The jet structure of 3I Atlas is not an accident. It is a highly complex physical consequence of an unnaturally stable, structured, and resilient internal core. The rigid channels, the controlled pulsing, and the magnetic resistance all confirm that this is a differentiated, engineered body. The coherence, the perpendicularity, and the resilience of the plumes confirm that this is a highly structured object. The latest image analysis has, finally, delivered the definitive visual proof that we are not dealing with a simple comet, but an object designed to withstand and operate in the extreme environment of interstellar space. The silence from the institutions is now deafening because the latest data leaves no room for simple cometary explanations. The straight jets, the symbol of the object's defiance, have now forced a complete, irreversible rewrite of the cosmic textbook. This is not a fuzzy comet that got lucky. It is a dense, high-velocity, channeled object that has delivered its final, compelling piece of visual evidence. The mystery is not solved. It is simply upgraded. A colossal wave of energized plasma, a massive coronal mass ejection, just erupted from the Sun and is hurtling through space, heading directly for our most baffling cosmic visitor, 3I Atlas. This is not a drill. This is a direct, unpredictable collision between one of the most violent solar events and an object that already defies every single law of physics we thought we understood. NASA, which has spent months desperately trying to minimize the anomalies of this interstellar comet, has been forced to break their silence. They cannot ignore this. It's a sudden, high-stakes threat that instantly turns the study of 3I Atlas from passive observation into a live, unpredictable scientific experiment. Forget the dusty arguments about chemical ratios and weird acceleration for a moment. Right now, we are watching a potential catastrophic impact that could either tear the object apart or, far more interestingly, reveal a core so structurally robust that it confirms our deepest suspicions about its unnatural integrity. The universe just cranked up the pressure, forcing the truth out of this mysterious rogue object. An invisible geomagnetic storm is about to test whether 3I Atlas is merely a fragile ice ball or something much, much harder. The most critical hours of the Atlas flyby are happening right now, demanding immediate answers. The silence is over. The world had settled into NASA's narrative. 3I Atlas is just a comet, albeit an odd one. This calm was carefully constructed, relying on a managed release of data that downplayed the true anomalies. We saw the chemical imbalance, the nickel without the iron, and the straight-line jets, but the official line held steady. Now, the Sun has shredded that carefully managed narrative. This incoming coronal mass ejection, or CME, changed everything. NASA's calculated reticence about the object's strange features became instantly untenable the moment the CME was confirmed on its path. The new urgency isn't about discovery, it's about crisis. They are now scrambling to gather data on the object's resilience, which means they must implicitly admit the object is strange enough to warrant this emergency observation. This unexpected solar flare-up means all hands on deck, forcing astronomers to rush new observation requests to ground telescopes and orbital assets like the Hubble and James Webb. The silence they maintained for so long has been shattered by the sheer violence of our own star. The very act of confirming the CME's trajectory toward 3I Atlas is NASA's implicit admission that this is not a standard, easily predictable comet. Why else would they mobilize their entire deep space observation network for a random ice chunk? The true measure of the object is about to be taken in fire and plasma. What exactly is this CME, and why is it so dangerous to a cosmic traveler? A coronal mass ejection is a massive burst of solar wind, magnetic fields, and plasma ejected from the Sun's corona at millions of miles per hour. This one is particularly energetic and happened to be aimed perfectly at the path 3I Atlas is currently traversing. When this high-energy plasma hits the object's coma, the thin, fuzzy atmosphere of gas and dust, it creates an enormous, chaotic geomagnetic shockwave. For a typical comet, this impact would be visually dramatic but often leads to fragmentation and disintegration, as the weak structure is stressed. The CME is a chaotic cosmic battering ram, capable of ripping away layers of material and stripping the tail. For 3I Atlas, with its known structural peculiarities, the threat is magnified, but so is the scientific opportunity. This is nature's own extreme pressure test, a forced experiment to see if the object's core can withstand an onslaught far beyond gentle solar heating. The magnetic field embedded in the CME is the key. It's about to slam into the object's own weak magnetic field, and the resulting interaction will be the most revealing observation of its entire flyby. This solar violence gives us the rare chance to measure the object's true density, its rigidity, and its resistance to total disruption. The moment of predicted impact is the most high-stakes cinematic event in space observation right now. Astronomers are bracing themselves for the immediate effects. We anticipate an enormous, sudden brightening of the coma as the plasma violently strips away material, causing a visible shockwave. The key signature will be the disruption of the tail. Comets have two tails, a dust tail and an ion tail, the latter being directly affected by the sun's magnetic field. The CME is a massive magnetic field anomaly, and when it hits, the ion tail will likely detach completely, an event called a disconnection event. But here is the critical difference. If 3I Atlas is structurally fragile, the nucleus itself will show stress fractures or even major fragmentation. If it's robust, the disconnection event will be clean, and the straight jets will resist the magnetic bending. The plasma will superheat the object's surface, forcing new, deeper layers to instantly sublimate, releasing a flurry of never-before-seen chemical signatures. Imagine a natural object subjected to a particle accelerator, and you start to grasp the scale of this forced interaction. This is not a gentle, passive flyby anymore. It's a cosmic brawl that will reveal the core strength of our interstellar visitor. We need to focus on the stability of the nucleus when the magnetic storm hits. This CME is the ultimate stress test for the object's inherent alien integrity. We already know 3I Atlas possesses that weird, unbalanced chemistry. The nickel without the iron. A traditional comet is a weakly consolidated mix of ice and dust. If that is what 3I Atlas is, the CME impact should cause a chaotic, randomized material loss. If, however, it possesses a denser, more structured core, perhaps the source of the straight jets, it will survive the magnetic shockwave with minimal structural damage. The magnetic fields within the CME will interact differently with metal-rich areas versus icy areas. A metal-rich core would damp the shock and maintain stability. An ice ball would explode. The CME is essentially a probe, forcing us to observe the object's reaction to extreme, non-gravitational forces. If the CME impact fails to fragment it, that resilience immediately becomes the strongest evidence yet against the simple comet classification. This is the moment the true nature of 3I Atlas will be physically tested, and the outcome will be binary, total disruption or total confirmation of its exceptional nature. Our telescopes are now looking for a definitive measure of its survival, a test of fire for an object that simply shouldn't be that strong. The CME impact presents an incredible, accidental opportunity for unexpected chemical revelation. The previous outgassing only allowed us to sample the outermost, most volatile layers of 3I Atlas, which is how we found the strange nickel signature. The high-energy plasma from the CME, however, will strip away that surface layer, digging deeper into the nucleus than any solar heating has managed. This forced sublimation could expose materials hidden beneath the volatile surface ice, allowing us to sample the true bulk composition of this interstellar rock. What if the missing iron is actually buried deep within a dense core? What if the interior contains complex silicates or unknown carbon compounds that our instruments couldn't detect before the impact? This is the core sampling event we couldn't have planned. The sudden, violent shedding of the outer shell acts like a chemical peel. revealing the pristine, never-before-seen ingredients of an alien stellar system. Every molecule released during the shockwave will be a window into the building blocks of another star's planetary formation process. This catastrophic moment is actually the deepest insight we will ever get into the object's fundamental makeup. The most dramatic moment of the entire observation period will be the CME's collision with the forbidden geometry. Those razor-straight jets were previously baffling enough, suggesting an unnatural symmetry or highly ordered ejection mechanism. The key test is whether they can maintain their perfectly straight orientation under the immense chaotic magnetic pressure of the CME. Standard cometary jets would be instantly warped, twisted, and scattered by the magnetic field embedded in the plasma cloud. If the 3I Atlas jets remain straight, if their geometry holds firm, it confirms an unprecedented ejection velocity or a level of structural engineering we cannot explain. This would move the hypothesis needle strongly toward the non-natural, demanding a re-evaluation of every observed feature. We're about to see if nature's chaos can destroy the object's internal order.